Hi, and welcome to Jackson's review of everything that we have learned so far in Java. Let's say we were working at a car dealership that sells 6 different types of cars. Each of those cars have certain characteristics, like their make, their top speed, their cost, color, etc. Using those characteristics, we could figure out other things about the car, such as their fuel efficiency and mileage. This example is a lot like how classes, objects, methods, and instance variables relate to one another. A class is a template. Every object of that class will share the same types of characteristics, like brand, fuel capacity, the same kind of things I mentioned before. In this case, the car is the class. Each individual car exists under that blueprint, each varying slightly from each other in those intrinsic variables. For example, some cars are red, some are blue. There is no memory held by the class since the blueprint does not hold intrinsic values. They just hold the blueprint. That means that they're different for each individual car. That is why the objects are the specific cars, for example, a Subaru Outback, Ford F-150, Bugatti Veyron. There are two different types of classes, public and private. Public classes are used to store data that can be used by other classes. Anything that is calculated or declared within a public class can be accessed by the other classes. For example, if we were looking at a car class in a database that calculates stuff like maximum fuel capacity, we would need the class to be public in order for the main to access that information. There would be no reason for that to be private also, since that information cannot be found on the internet. Now, private classes are used to store data that cannot be used by other classes. What's declared and calculated in a private class is only accessible from that class. In order to do this, we need to make use of the concept of encapsulation, which means that the data inside the object/class is hidden, which prevents unauthorized access. For example, if we were looking to create a banking system, that information needs to be private, or else it would be public information for anyone to access. Classes can also be classified under parent or child. Now, parent or child classes are yet another example of the benefits of object-oriented programming. Let's say we had a calendar application with many different types of events, such as goals, assignments, tests. Now, all of these events will have a year, a day, a month, a minute that the event is happening at. However, some variables will be different depending on what kind of event it is. For example, a goal doesn't require studying like a test does. Therefore, while there are some variables that are used in every object, others are specific to certain kinds of events. We can use those parent and child classes in order to make our code way more efficient. By creating a parent function, we can put the instance variables that exist in all of the objects into that constructor, which is a concept I'll get into later, and then extend the common variables into the specific child classes. At no point will there ever be more than one parent. When a child class takes instance variables from a parent class, this is called inheritance. Now, there are 3 kinds of inheritance. The first kind is single inheritance. That is when one parent passes down instance variables to one child. Multi-level inheritance is where you have one child, one parent, and one grandparent. That means that the child inherits traits from the parent, and the parent inherits traits from the grandparent. You also have hierarchical inheritance, which means that there's multiple children but only one parent. I started talking about objects in the class section, but now we're going to go into them in more detail. Now, in the example that we were talking about before, the cars were the objects, because each of them fall under the category/template of a car, and they all share the same types of characteristics. These characteristics are called instance variables because depending on the type of car, from instance to instance, each specific object will have different instance variables. For example, some cars are blue, some cars are red. Some cars are slow, some cars are fast, some are efficient, others are not. There are 3 different parts to an object: its state, its behavior, and its identity. The state of an object is its instance variables. These would be things like the fuel burn rate, the color, the type of any car. The behavior of the object would be its actions, such as drive, park, etc. And the identity of the object is used within the IDE or the Java virtual machine, which gives each individual object an ID that the user and the coder don't actually see. The intrinsic traits that every object has falls under 8 different primitive types. These types are byte, short, int, long, float, double, char, and boolean. Now, each of these different types does a different thing. For example, a boolean holds either a true or false, a char holds one character, a double holds a very long value, and an int can only hold whole numbers. Now that we understand all the theoretical aspects of classes and objects, we can now get into the actual coding. Now, this is our ADE. Up here, you can see it says main.java. This means that this is our main class, which means that everything will be happening from right here. Now, this program will be a car database. We'll be looking at different cars and their certain traits, and then we will be calculating certain things based on those traits. So the first thing that we're going to want to do is create a car class. So what we need to do is open up our source folder and then open up our com.company folder and create another class alongside the main. Now, this class is going to be called the car class, which means that everything to do with cars will exist within that class. The first thing that we're going to do is we're going to define our instance variables. Now, these variables are what every car has. So every car has a certain amount of passengers that it can seat. Every car has a top speed. Every car has a fuel capacity. And every car has a fuel burn rate. Now that we've defined our instance variables, we can start creating the actual cars. So if we go back to our main, the syntax for creating an object, or in this case a car object, is the class name, so car, and then the name of the object. So let's say we're trying to make a Camaro object is equal to new, which is something you need to use when you create an object, the class name again, bracket, bracket, semicolon. Now the next thing that we need to do is we need to define the instance variables for that specific object. So how we do that is we go name of the object dot, let's say, passengers. And remember, we defined passengers over here. So it knows what the 4 instance variables that we're looking at are. Equals, let's say it can see, I think, 4 passengers. And then another instance variable, it's top speed. Let's say we're in kilometers per hour, 150 kilometers per hour. Fuel burn rates, say 30. Fuel capacity, say 150. And we have now just defined all of the instance variables for our Camaro object. We can create as many of these car objects as we want. Let's say we want to make another one. All right, how about car Ford F-150 is equal to new car. And then we need to give this object its instance variables, or else they will all just be left at null. So I think we do 2 people, say 100. Oh, whoops. Since it's a truck, its burn rate is probably going to be a little higher. Let's say 50. And we'll leave the capacity the same. So we have now just created 2 objects within our car class. Now that we've learned about regular instance variables, we can learn about static variables. Now, a static variable means that it's a constant, which means that it cannot be changed. Now, all cars have 4 wheels, right? Which means that we can say static int wheels equal to 4, and every car object that we create will always have 4 wheels, and that will never change. Now that we've defined our objects, we need to be able to perform actions with them. This is where methods come in. Methods are blocks of code that perform some kind of operation using the instance variables of the objects. For example, if we had the car's gas usage and we also had its fuel capacity, we can measure its efficiency. When we build programs, the goal is to make the main as small as possible so that it's easier to read and organize. This means that the vast majority of our code will be methods calling other methods. Anything can be done in a method other than starting the program. That's what the main is for. This could be output, input, calculation, etc. There are many different types of methods depending on the goal of that function. For example, if we didn't want to return a value and just output a message, we would use the void method. If we wanted to return the fuel efficiency of the car, we would use a double method in order to return the final fuel efficiency where the method was called. Now that we understand how methods work, we need to actually apply them into our car program. So, let's say we're trying to calculate fuel efficiency. We're going to need to use a double because it's probably going to come out as a decimal, which means that we need to return a double value. So let's create a new method, double calculate efficiency. Now, first thing we need to do is we need to define the variable efficiency as a double. Then we do the actual calculation. And then we return efficiency back to where it was called. You can probably already start to see how much more efficient our code gets when we add methods. As we add more functionality and car objects to the program, you can imagine how big the code will get, and that's why methods are so important. In order to make our program easier to understand for the user and the programmer, it's essential to break up our program into logical pieces. They allow us to organize our code into blocks, which makes it much easier to A, organize code, B, it allows us to use the function more than once rather than writing the entire code all over again, and C, it makes the growth of the program a lot easier while reducing the total line size. Let's say we needed a second method. This time we needed to look at the fuel required. So in order to do that, we obviously need the fuel burn rate, but we also need the time. Now the time isn't an intrinsic variable because a car doesn't have a certain amount of time. So that's a value that you need to get from the user. This is where parameters come into play. Now, a parameter is when you pass in a value into a function and then return the final value. Alright, so let's start making this function. So, it's going to be a double because it's going to give us back a fuel needed value, and that value is probably going to be a decimal. Double time. So this is where we put the parameter, and this is when we call the function, we're going to insert this value into where we call it. So we're going to initialize a variable here, and we're going to do our calculation. Is equal to fuel burn rate times time. And then we just return this value back to wherever we called it from. So let's say we wanted the user to input how many hours they would like to be driving for, and then the program would spit out how much fuel they need. So let's create a little system out here to ask them how long they would be driving for, and then we create a variable which will take in that value. Then what we need to do is make a line where the program will tell you how much fuel you need. So basically what's happening here is first we're making sure that the program knows what object that we're looking at, which is the Camaro, and then we call a specific method, and then we put the hours integer into here. And we should end up with a final value. say we'd be driving for 3 hours, and it gives us a final fuel required of 90, which makes sense because 3 times 30, which is the Camaro's fuel burn rate, is 90. When creating objects, there's tons of overhead creating and initializing the object line by line. Initializing tens of variables with only one per line will clog up the code, making it less efficient. Constructors allow us to have all of that information on one line. As you can see here, it's already starting to get a little bit cramped, and we only have 4 variables. In a regular database, you would have way more than that, and so that would cause a lot of problems with your program. Now, a constructor acts very similarly to a parameter method. Essentially, we send instance variables from the main into a method, in this case a constructor method within the car class, and then we set those variables equal to local variables within that car. So the first thing that we're going to do is we're going to go into our car class and we're going to create a new method. And this method is going to have the same name as our class. And then since we have 4 variables here, we're going to do int a and b and c and double c double d. Now, once we have this, we can do passengers is equal to a, cruise speed fuel capacity is equal to c, and fuel burn rate is equal to d. So essentially what we're doing is the main is going to pass values through this method into here, and then we're going to set it equal to these local variables. So the thing that we need to do in the main is we need to change how we've done our function here. And you can see that we have a whole bunch of errors because it's expecting parameters here. So we essentially need to move these values up into here. So 4, 150, 30, and 150. And 2, 100, 50, 150. Now, once we've done this, this is essentially doing the same thing as we're doing down here, just in way less lines. So now, if we wanted to test whether our program was operating the same as it was before, we can run the main and test out our fuel required function, or method, sorry. So if we're driving for 3 hours, it should come up with 90, just like it did before, because 3 times 30 is 90. One thing you may have noticed is that we seem to be using this dot operator method a lot. So system.out.println, system.in.nextInt, Camaro.fuelRequired. And the reason we do that is to organize our code a little bit better and give it sort of a hierarchical format. So basically how it works is that under the car class, we have 2 methods. We have fuel required and we have calculate efficiency. Now, if we were to just write Camaro here with no dot, it would not know which of the functions to use. So we need to actually write in fuel required to make sure that it knows what it's supposed to be doing. Same thing with this system. If you just wrote system dot, there's a ton of different options down here for what it could be doing. But we want specifically it to output, and then even within that, there are many different things that it could output, so we want it to specifically print line, which means that it's printing whatever you want, and then it's printing an enter after that. So up until this point, we've been dealing with a set of variables that are the same for every object. Every object has passengers, every object has a top speed, every object has a fuel capacity, every object has a fuel burn rate. But what if some objects required more instance variables than others? For example, what if there was no fuel at all? What if we were dealing with a Tesla? So let's create a Tesla object. Car. And it can seat 4 people, and it has a top speed of 150. But we have an error here because we're not giving it enough variables, right? you can see down here that it's requiring a double, and we're only giving it an int and an int. So this is where overloading comes into play. What we can do is we can create another method or another constructor under the same name as the other, but just have it take in less variables. So when we construct this one and it calls this car method, it's going to notice that we have less variables than the other, so it's going to work with this specific method and not this method. And top speed equal to b. So when it constructs this Camaro one is going to be using this one, this F-150 one is going to be using this one, and the Tesla one is going to be using this one because there's only passengers in top speed, they aren't dealing with fuel. One thing that is sometimes used in methods and constructors is the this keyword. Now the this keyword is put in front of any of your instance variables. For instance, you could put it like this.passengers and this.top speed. So what does this do? Well, the this.operator actually isn't that useful if you have good variable names. For example, if you had two objects that had the same name, then you might run into some problems. But if all of your variables have good, meaningful names, you probably won't need to use this. It just makes it easier for the IDE to figure out exactly what you're using if everything else is not clear. Okay, now we are going to look at the toString method. Now the toString method just makes it easier to display all of the variables within a certain object. So you're going to want to go into your class, public string toString. So basically what this is going to do is it's going to look at your object and it's going to return whatever string, whatever values, and then put it into a string. So let's say we wanted to do car, and then finally the fuel capacity. So if we take this, and then we wanted to display everything that's inside of our Camaro. So we could do system.out.println, and then Camaro.toString. Now this is going to display all of that information onto the screen. See, it tells you it's a car, it has 4 passengers, it has a top speed of 150, has fuel burn rate of 30, and has a fuel capacity of 150. Make this look a little nicer if we just put some \n in here, just to make it easier for the reader to understand. And there we go. We have all this information here, easy to read for the user. Exception handling is an extension of error handling that is now necessary in Java. These are not the same as errors, as an exception will break the program, while an error is simply the wrong input, not necessarily something that results in a crash. There are many different types of exception handling, such as array index at a bounds exception, class not found exception, file not found exception, no such method exception. Most of these are pretty self-explanatory. Any one of these exceptions will crash your program, which is why it's important to make sure that they never happen. This is done through try-catch block, which essentially checks if the exception is true, and if it is, it catches it, and then the user has to try again. JOptionPaint is a super useful method when you are trying to get user input and user output, not through a console window, but instead a display. So instead of using this java.util.scanner, we're instead going to import another class, javax.swing.start. And the star just means that we're importing all of this swing stuff. And see how it's blue because we're actually not using it right now, and we're using the scanner instead. And then if we take out this scanner line, it's going to make this blue because we're no longer using it, and it's going to make this one colored. So what we're going to do is we're going to take out this try-catch. And essentially what the JOptionPaint does is it changes it into a string, which means that we are going to need to turn the hours into a string, and then later we're going to need to turn it back into an integer. So how this works is hours is equal to JOptionPaint.show input dialog, and then you can just replace this line and put it in here, and essentially that's going to be the title of this display window that's going to pop up. And then once you've done that, you need to do int hours equal to integer dot parse int hours. So essentially what we've done here is we've taken out the use of the java.util.scanner and we're using display instead. And we're using JOptionPaint, and then this is the title. And then there's going to be like a little input dialog box. When the user enters that, it enters as a string, and then using the parse int, we change it into an integer and then put that into our camaro.fieldRequired method. And then if we would like to test that method, all we need to do is run. And there should be an input dialog box that comes up. How long will you be driving for in hours? 3. And then if we go down into our terminal, it's going to come up with 90 because 3 times 30 is 90. This is the final part of the coding review. So we are going to be looking at commenting. And I specifically left commenting for last because I wanted to emphasize how important it was. Commenting is one of the most important parts of coding, and it's not even really coding. But if you can't comment effectively, you probably don't understand the code that you're writing, or you just need to spend more time with it. There are lots of benefits to your code if you can comment effectively, including but not limited to A, allowing non-coders to understand what you're trying to do, B, it helps other coders figure out what you're trying to do so they can assist you, and C, if you're working on something else for a while and you forget how a certain method or class works in this program, the comments remind you. Your comments need to be clear, concise, and easy to understand. The way that I check to see if my comments are effective is getting someone that doesn't understand code to look at my program. If they have a basic understanding of what is happening, then great, your comments are well done. If not, they need more work. So here are some examples of good commenting within a program. So right here, we are creating the object and we are sending it to a constructor within the car class. So I'm going to write creating Camaro object using constructor. Clear, concise, easy to read. Down here, we are using the toString method to output all of the information about the Camaro. Outputting to console the data, the variables of the Camaro. You could even write characteristics just to be even more clear. Generally, in your comments, you don't really want to use coding language because that makes it harder for normal people to understand. Another example here. casting the string as an integer in order to use it in the fuel required function method in the card class. You're going to want to do comments for every single one of these lines just to make sure that everything is crystal clear for anyone looking at your code.